Alright, hello everyone. I hope you guys are doing great. So today we have this Codeforces Round 790. So this is a Division 4 round and hence it won't be rated for me. That is why I thought about recording a screencast for this round. So I'll be recording my attempt, and if I'm able to solve all the problems, then I will try to even do the solutions to all the problems at the end of this video, right? So yeah, let's see how it goes. Alright, let's start. So a ticket is a string consisting of 6 digits. A ticket is considered lucky if the sum of the first 3 digits is equal to the sum of the last 3 digits. Output it whether it is lucky or not. Alright, I see. So this is just simple brute force. S1, S2, S1 is equals to 0, S2 is equals to 0, S1 plus is equals to S of I minus 0, and S2 plus is equals to S of I minus 0. If S1 equal to S2, then the answer is going to be yes, otherwise the answer is going to be no, right? Alright, so let's submit this. There seem to be a lot of problems here. So there are 9 problems. Wow, that's a big number. Okay, so let's go to problem B now. So there are n boxes with different quantities of candies in each of them. Ith box has AI candies inside. Alright, so you have n friends that you want to give the candies to. So you decided to give each friend a box of candies, but you don't want any friends to get upset, so you decided to eat some candies from each box so that all boxes have the same quantity of candies in them. Note that you may eat a different number. What's the minimum total number of candies that you have to eat? I see. So we just have to subtract the minimum element from all the elements, right? Okay, I see. So we just have to make all the elements equal to the minimum element. So minimum element is going to be this, and then we just have to subtract it, right? So A of I minus Mn. So this should probably work. Okay, let's submit this. Alright, let's move to problem C now. So we have n words of equal length m consisting of lowercase Latin letters. Ith word is Si. So in one move we can choose any position in a single word and change the letter at that position to the previous or next letter in the alphabetical order. A can only be changed to B and Z can only be changed to Y. I see. So there is a long queue, it seems. The difference between two words is the minimum number of moves required to make them equal. The difference between best and cost is this. Okay, find the minimum difference between Si and Sj such that I is less than j. In other words, find the minimum difference over all possible pairs of the n words. Okay, looks like a simple brute force. So let's just have a function, right? Min difference, which takes in two strings and returns the minimum difference between them. Okay, so are the sizes of all the strings same? Yeah. Okay, alright, so the best way to convert is either taking the absolute difference or first going in the reverse direction and then making them equal, right? Okay, so we have two values, d1 and d2. So d1 is just going to be the difference between the two characters at this position, which will be s1 of I minus s2 of I and the absolute value of this, right? Now what will be d2? So basically for d2 what we are doing is also we have to divide this by 2, I guess, because we have to take the ceiling. Yeah, because in one operation we are getting a benefit of 2, right? Yeah, so in one operation we are getting a benefit of 2. Oh, in a single word. Okay, so this is not here. And the other thing that we can do is, first we can convert the first string to A, right? And then we can convert it to the second string in the reverse order, obviously. So for that, the number of operations that it will require is, so to convert s1 of I to A, the number of operations required will be something like this, first of all, right? So if s1 of I is A, then it won't require any operations. And then for z we are getting one operation, and for y we are getting two operations. So that means we have to add 26 minus s2 of I minus A, right? And then we can just take the minimum of them, right? Yeah, so if I put s2 of I is equals to z, I'm going to get 25 here and I'm getting 1 here. Yeah. Makes sense, makes sense. I'm getting n and m. Alright, n lines follow, we will get 2 strings. Okay, let's take this vector. J goes from I plus 1 to n minus 1. And what did we have to do? Minimum difference, right? So let's initialize the answer by infinity. And answer will be minimum of answer and min difference of s of I, a of I and a of j, right? Let me just cross check this formula. The first choice is to just convert the first character to the second character. Okay, second choice is to first convert the first character to A, which will require s of I minus A operations, right? Yeah, and then I have to convert it to that character, which will require these many operations. Yeah, seems fine. Let's see. Okay, so I'm getting 11 and I'm getting 2 here. So let's try to debug this. Let's see, 0 and 1, that seems weird. Okay, so there are only 2 strings here, I see. So this is definitely wrong. Alright, let's just try to output stuff. See where I'm going wrong. Oh, I see. So this should be 2 here. So oh, I see, we can't do that. So d2, the concept of d2 is not there. We just have to do this. I see. This should work now. That was pretty stupid of me. If you are watching this, then this is something that you should never do in a contest. You should always try to read the problem first and try to understand what it's saying. Anyways, so Timur's grandfather gifted him a chessboard to practice his chess skills. This chessboard is a grid of n rows and m columns, with each cell having a non-negative integer written on it. Timur's challenge is to place a bishop on the board such that the sum of all cells attacked by the bishop is maximal. The bishop attacks in all directions diagonally, and there is no limit to the distance which the bishop can attack. Note that the bishop is on a cell. Okay, so we have to find the maximum sum. Can we brute force our way here? Looks like we can. So the sum of nm is never exceeding 4 into 10 to the power 4, and then we can have a 200 there, right? Okay, although it's possible to do this without brute forcing it, but I don't really care here. So yeah. So let's try to write it. We have to find the maximum sum, right? Yeah. So we are placing it here at I comma j. Okay, now first we'll try to go up. Okay, so what that will do is, so let's try to go d distance up. While valid of I plus d, or maybe something like this, we will simply go. So the maximum distance that we can go up is definitely maximum of n comma m, right? And let's try to write a valid function. So now we are going up, so our x coordinate is decreasing, our row is decreasing by 1 and the column is increasing by 1. So we are basically at the cell I minus d and j plus d. Okay, let's just make n and m global so that we can write a valid function. So what we have to do is, r is greater than 0 and r is less than equals to n, and c is greater than 0 and c is less than equals to m. Okay, so we'll declare our current sum as 0 or maybe as aij. Okay, so if valid of I minus d and j plus d, sum plus equal to a of I minus d and j plus d. Okay, similarly now we are going down to the left by d. Okay, so I think we can add it here only. So now our row is increasing by d and basically column is decreasing by d. So we are here, so sum plus equals to a of I minus d j plus d. Next we are going up and to the left. So for that what happens is, our row is decreasing by d and column is also decreasing by d, and then we'll go down and right. So for that what happens is, so we have to check if I plus d and j plus d is valid. So sum plus equals to a of I plus d and j plus d, and then we'll just say answer is equals to max of answer and sum. So this is how we can solve this problem. Okay, so what's going on here now? R greater than 0, R less than equal to N, C greater than 0, C less than equal to M. Sounds okay. Okay, let's see. Yeah, so we are getting a runtime error. There are n rows and m columns. Things seem fine here. I minus d, j plus d, I plus d, j minus. Okay, so I spot a problem here. This should be I plus d, j minus d. Should be fine now, I guess. Okay, let's submit this. There seems to be a long queue today. Okay, let's look at problem E now. Okay, so we have n candies yet again, and the ith candy has a quantity of sugar equal to ai. So by eating the ith candy, we consume a quantity of sugar equal to ai. So we have q queries, and for the jth query we have to answer what is the minimum number of candies we need to eat in order to reach a quantity of sugar greater than or equal to xj, or print -1 if it's not possible to obtain such a quantity. Okay, so this seems easy. We just have to do a binary search here. And q, and then we have all the array elements. So we have to binary search on the prefix sum, right? Oops, I'm sorry, we first have to sort the array, then have to do prefix sum. So p sum of I is p sum of I minus 1 plus a of I. Alright, so now we have q queries. So in each query we just have a number x. Okay, so we have to print greater than or equal to x. Okay, so we just have to find the lower bound. So if j is equal to n plus 1, then answer is -1, else answer is j. Okay, let's see. Okay, this works, so let's submit it. Okay, so we are done with 5 problems. Hopefully 4 more to go. Alright, So we have an array A of length n and an integer k. We are asked to find any two numbers L and R such that for every x in between L to R, x appears in A at least k times. That is, k or more array elements are equal to x. And the value of R minus L is maximized. If no numbers satisfy the condition, output minus 1. Okay, I see. So we need to find L and R, right? Such that every element which is present between L and R has a frequency at least k. I see. Okay, so maybe we can iterate on L and then try to find a plausible value of R. Or maybe not. Probably we can try to iterate on the length of the subarray that we are choosing. Elements are large, that's one thing. We have to find the subarray in which the frequency of all elements is greater than or equals to k, and we have to find the largest such subarray. Just subarray. What we are interested in is the minimum frequency of any element present. Okay, let's look at problem G first. So we have given a rooted tree consisting of n vertices. Root is at vertex 1. There is also a string s denoting the color of each vertex. So there are black vertices and then there are white vertices. Number of white vertices is equal to the number of black vertices. So we have to count the number of balanced subtrees. Okay, so this looks pretty straightforward, so I'm going to do this first. We can simply simulate this. we just have to find number of white and black subtrees is same, right? Okay, we have B and W. Okay, let's say that or we don't even need the color here. So we'll say that black of I is 1, else we'll say that white of I is 1. Okay. Okay. Now let's just build the tree first. Wait a second, what is the root of the tree? We are given a rooted tree and vertices from 1 to n. All trees have root 1. Okay, alright, that's good. So we just have to do a DFS from 1 . So white of Carnot plus equals to white of X, black of Carnot plus equals to black of X. Okay, cool. Alright, so we have to also declare an answer variable. Answer plus is equals to black of Carnot equal to white of Carnot. Okay. Alright, let's submit this. Hopefully it will pass. Okay. This is really unexpected. Okay, what's going on here? Oh, okay, so we have something like this. Right. Okay, now it's fine. Let's submit this. Maybe we can even go for problem H first. N is less than 1000 and the sum of n over all test cases doesn't exceed 1000. Okay, what about H2? Okay, a terminal is a row of n equal segments numbered from 1 to n. Okay, there are two terminals, one above and one above the other. Okay, you are given an array A of length n. There should be a straight wire from some point on segment I of the top terminal to some point on the segment AI of the bottom terminal. For example, the pictures show two possible wirings if n is equals to 7. I see. points can be anywhere. Alright. A crossing occurs when two wires share a point in common. In the picture above, crossings are circled in red. What is the maximum number of crossings there can be if you place the wires optimally? I see. When will there be a crossing? The first segment covers portion from x equals to 1 to x equals to 2. Second segment covers portion from x equals to 2 to x equals to 3. So when will basically there be a crossing? When can two wires cross? So we have a wire going from I to AI and a wire going from J to AJ. So we have to check whether they will cross or not. How do we do that? If J is greater than I, so let's create a new file. So we have I and J, where J is greater than I, and we want to check if the jth wire will intersect with the ith wire, and the way that can happen is only if A of I is greater than or equal to A of J, right? If A of I is equal to A of J, even then they can intersect. But if A of J is greater than A of I, then obviously they are never going to intersect. Because they are straight wires. Yeah, makes sense. So how do we check this? First, let's try to check if it's correct or not. Yeah, it is actually correct. Let's submit H1. So basically in the suffix from I plus 1 to n, we just have to check how many values are smaller than or equal to A of I. So I'll do this with an ordered set. So we have to count the values which are smaller than or equal to. So for that we will do A of I and infinity, right? Okay, this isn't working. Oh, we have to go in reverse order. Yeah, seems to be working fine. Okay, so the only problem remaining now is F, I guess. Alright. Okay. So we have to find the largest segment such that the frequency of each element in this segment is at least k. Let's see. N is large, so we can't do something like a range TP. Has to be something easier than that. Let's try to find a relation between the value of r for a particular L and the value of r for L plus 1. Okay. If a of I is equal to a of I plus 1, then the value of r for I will definitely be equal to the value of r for I plus 1 and plus 1. Okay. But if that is not the case, if a of I is not equal to a of I plus 1, then what happens? Then we have the value of r for a of I plus 1. Okay. The only difference between these two is the element a of I. Okay. So then we'll check what is the frequency of a of I in the values of L and R for a of I plus 1. Okay. Moving here. Okay, that's not how we're supposed to do this. Use L and R such that I don't think we can apply binary search here as well. Okay, let's see. Here, let's say if we start at 11, then we can end here. We'll go there. If it exists, then we will go there. Let's try to do some kind of DP here. frequency of all elements exceeds k. Let's think about this. K can take any value from 1 to n. Should come 2 times. So 1k condition satisfied. Okay. 9, 12, 10, obviously. 12 should appear k times as well. Okay, just give me a moment. Frequency of each element exceeds k. In this suffix we will try to find out its frequency, and that can be done using count. We can look at its mass occurrence also. Yeah, this is always only on the mass occurrence of some character, right? Occurring in the mass occurrence. Okay, wait a minute. Why is the answer not 1 and 5 here? Am I missing something or what? Okay, you are asked to find two numbers L and R such that X appears in A at least k times. Okay, X appears in A at least k times. Damn it. I thought it should appear in the subarray at least k times. That's my bad. Okay, I completely misread the problem yet again. Wow. Okay, I'm so sorry. So we just have to find the longest contiguous segment. Wow, that's bad. Okay. So then what we'll do is we'll have something like this. So if x dot second is greater than or equals to k, then we'll have good of x dot first is equal to 1. Okay. X in good. Now what we'll do is longest segment, right? So LL curve is x dot first. So good of curve plus equals to good of curve minus 1. Maybe we can have a vector of pairs. So if x dot second is greater than or equals to k, then we'll push something like x dot first and 1. Then we'll sort the vector. So now what we'll do is, if vec of I minus 1 equal to vec of I, we'll have an array good. Size n with 1. Then we'll have good of I is equal to good of I minus 1 plus 1, else good of I will just be equal to 1. Answer is max of answer and good of I. Hopefully this will work. Okay, so I also have to do this. Two, 3, 0, 4. Okay, makes sense. So if good of I is greater than or equal to answer, then what we'll do is answer will be equal to good of I, R will be equal to I, and L will be equal to R minus I plus 1, right? If L is equals to minus 1, we will simply output minus 1, otherwise we'll output L and R. Okay, this should be vec of I. And this should be good of I. Okay, makes sense. Hopefully this is going to work. Alright, so all in all, I read problem C wrongly and I read problem F wrongly, which costed me around half an hour in this contest. So I am not satisfied by my performance at all. Yeah, so my rank is also not pretty good here. But I'm quite surprised that it is better than second thread. I'm really surprised. Anyways, so the contest was just very ideal as a div 4 contest. That is what I would say. All the problems were really easy, and they were really beginner friendly, I would say. Yeah, so that is my take here. And now I think it's a good time to go over the solutions, right? So let's just quickly go over all the solutions. I mean, I won't be doing a very detailed analysis here because I don't think these problems deserve that. So let's just start with the solution to problem A. So here we have a definition of a ticket, which is a string consisting of 6 digits, and we just have to check if the first 3 digits are equal to the last 3 digits or not. So there is a very easy way to do that. We can do something like this. If you want to write it in one line, so if s dot sub str 0 3 is equal to s dot sub str 3, then we can say that answer will be yes, otherwise answer won't be yes. So yeah, basically it's a very easy problem. You just have to check whether the first 3 characters are equal to the last 3 characters or not. Okay, so moving on to the second problem now. So here there are n boxes, and all of them contain a different quantity of candy in them. We have n friends who we want to distribute the candies, and what we want to do is we want to give each of them equal amount of candies, right? Yeah, and to do that, what we'll do is we can eat some candies, some amount of portion of some candies, and we have to tell the minimum amount of portion that we'll have to eat so that all the friends get the same amount of candy. And the solution here again is very simple. What we can do is, since we want to minimize stuff, what we'll do is we won't even touch all the candies which have the minimum amount out of all the candies, and we'll make every AI equal to the minimum element in the array A. And to do that, we just have to subtract the minimum element from all the elements and add it. So the code goes something like this. First you find the minimum element and then you subtract that minimum element from every element and add that to your answer. Okay, so that is going to work. Alright, so this is problem B done. Now let's move to problem C. Yeah, I'm recording. Okay, problem C. So here we have n words of equal length, and basically we have to find the minimum difference between any two pair of words. Difference between two words is found by something like this. So we are allowed to do some operations and make the two words equal, and the difference between the two words is the minimum amount of operations that we have to perform, right? So the operations that we can perform is we can change every character either to its previous character or to its next character in the alphabet, but we have to keep in mind that we cannot convert A to Z and we cannot convert Z to A and vice versa. So A can only be converted to B and Z can only be converted to Y. Okay, so yeah, that's the problem. And the solution here again is pretty simple. So the difference between any two strings is basically just going to be the difference between their positions in the alphabet. For example, if you have to convert A and C to the same character, then the best thing is to just convert A to C, and the number of operations it will require is 2, which is the difference between the position of C and A in the alphabet. So what you can do here simply is to calculate the difference between two strings, simply add this value AB, the absolute value of S1 of I and S2 of I for each I from 0 to n minus 1. So this is how you can calculate the difference between two strings. So then you can just iterate over all pairs of strings and find out the difference between them. It's pretty easy to do that, and it will definitely fit in the time limit because the constraints here are pretty small, right? Okay, so yeah, that is pretty much it for problem C. Now let's move on to the next problem, X sum. So here we have a chessboard of n rows and m columns, and in every cell there is basically a number written, a non-negative integer written. What we want to do is we want to place a bishop on this n cross m grid, and we want to tell where we should place a bishop, so that if we take the sum of all the cells that the bishop can attack, that particular sum will have the maximum value. Okay, so that is the problem. So a bishop is basically a chess piece which attacks towards all the diagonals. So we basically have to find the sum of all the diagonals which contain our cell I comma j, and we have to do this for all the cells I comma j and take the maximum out of them. So the way to do that is to again simply write a brute force. Since the constraints are really small, if we iterate over each cell, that would take O of nm time, and then if we iterate over all the diagonal points, then it will take O of n plus m time. So the total time complexity still remains around 200 cube, which will definitely fit within the time limit. Okay, so the way to do this is let's just try to look at the code. What we do is we write a valid function which returns whether a particular cell lies inside the grid or not. Okay, this is a valid function, and then what we'll do is we'll simply iterate on the cell where we'll keep our bishop. Obviously our sum originally will be A of I comma j, because we will consider that the bishop is attacking the cell where it is at, and then we will go in 4 directions. Obviously there are 4 possible directions in which the diagonal can exist, so these are all the 4 possible directions that we'll go. Obviously we can only go till max of n comma m, and so what we'll do is we'll simply check if the particular cell is valid or not. If it is valid, we'll keep adding it to our sum, and we'll do this for all the 4 directions. So finally we'll have the entire sum of all the values that our current bishop can attack, and then we are just supposed to take the maximum out of them. Okay, so yeah, this is the solution to problem D. Now let's move on to problem E. Okay, so this is again a pretty simple problem. So what we have to do here basically is we have n candies, and we are given the amount of sugar which is present in each candy, and then we'll be asked q queries, and in each query what we have to tell is we have to tell the minimum amount of candies that we have to eat completely, so that the amount of sugar that we consume will be greater than or equal to the value x, which will be provided as a parameter of the query. Okay, so the logic here is again the same. We will try to consume the candies from the highest to the lowest, simply because consuming the candy which gives the highest benefit first will be the most beneficial for us, obviously. So what we can do is we can simply do a binary search to figure out what is the minimum number of candies that we have to eat. So you can write a binary search for it, but a simpler way to do it is first you build a prefix sum, first you basically sort all the elements in the array, and then you reverse them, and then you build a prefix sum. Okay, now you have the prefix sum, so you can apply binary search on this prefix sum to find out what is the minimum number of candies that we have to completely eat. That is, what is the first index where the prefix sum will be greater than or equals to x, and this is basically the definition of the C++ lower bound function. So you can just apply a lower bound on the prefix sum array, and if the lower bound gives you an index which is equal to n plus 1, that means that the answer will be -1. Otherwise the answer will be the index at which the lower bound pointer will point. Okay, so yeah, this basically completes problem E. Now let's briefly talk about problem F. Okay, so as you all already know, I misread this problem and I basically messed up big time here. So the problem is pretty simple. So what we have to do is we are given an array A and an integer k. Our task is to find any two numbers L and R such that for every element between L and R, the frequency of x in our array is at least k, and we have to find these values such that the length of the interval from L to R is maximized. Interestingly, what I assume this problem is asking is we have to find two indices L and R such that every array element which is present between these two indices has a frequency of greater than or equal to k, and we have to maximize the length of a subarray. It turns out that is not the problem, and the problem is much more easier than that. So the solution here again is pretty simple. What we can do is, first of all, we can so you can notice that the elements are quite huge, so we have to take a map. So we can take a map which will keep all the frequencies of all the elements present in the array, and then what we'll do is, for all the elements whose frequency is less than k, we can just assume that these elements are not present in the array because they are similar to elements which are not present in the array. The only elements we are interested in are those whose frequency is at least k. And when we have an element whose frequency is at least k, then we say that this is an interesting element. Okay, and then what we can do is we basically have all the elements, and we just need to find the longest length of contiguous elements here, right? So by that, what I mean is we have to find the longest chain L and R such that all elements from L to R are special. So this is a very easy problem. Now what we can do is we can simply do it using a DP. I mean, there are easier ways, but the way I did it is using a DP. So let's have a look at the solution. So first of all, I create a map where I count all the frequencies, and if the frequency of an element is greater than or equals to k, then I push it into a vector and say that it is a special element. Then what I do is I basically iterate at all the elements of my vector, and I have this array good of I. Good of I basically denotes, so good of I is the length of the longest good subsegment ending at I. Okay, so basically it means that if good of I is equal to x, then all the elements from I minus x plus 1 to I have a frequency greater than or equals to k. Okay, so I have this vector sorted with me. So what I do is I check if vec of I minus 1 is equal to vec of I minus 1. That means the previous good element is the element which is just before me. So in that case, good of I can simply be written as good of I minus 1 plus 1. Otherwise, we can say that good of I is equal to 1. Obviously, because the previous element is not good, so good of I will be 1. So now if good of I is greater than the previous maximum value that I have, then I can just say that R is equal to vec of I and L is equals to R minus good of I plus 1. Right, so this is pretty simple. So if L is minus 1, I just print minus 1. Otherwise, I print the values of L and R that I get. Okay, so yeah, this completes solution to problem F. Now let's talk about problem G. So this is again a very simple problem. I don't even think this deserves to be a problem G. So basically there is a tree. Now obviously for beginners, I think this is a good and educational problem. So the problem says that there is a tree with n vertices and every vertex is either white or black. So we need to count the number of subtrees such that we need to count the number of nodes such that the number of white and black nodes in the subtree of that node are equal. Okay, so what we can do here is we can just simply do a DFS and try and just pre-compute the number of black and white nodes in the subtree of each node, and if these values are equal, we increment our answer by 1, and that's it, right? So that is basically all I can say about this problem. right? So the solution goes like this: we just keep these two vectors black and white, which denote the number of black and white nodes in the subtree of our current node. So we do a DFS, and in the DFS we look at all the children of our current node. Let's say that a particular child is x, then what we'll do is we'll say that white of current node is plus equal to white of x, and black of current node is plus equal to black of x. And this is a simple, you can say this is a simple dynamic programming relation here. And then we'll just check if black of current node and white of current node are equal or not. If that is the case, we'll increment our answer by 1. Okay, and finally we'll just print our answer. So that completes the solution to problem G as well. Now let's talk about the last problem, problem H. I won't discuss H1, I will simply discuss H2 here. So what this problem is saying is there are these n segments and the length of each segment is equal. Okay, and basically what happens is we have been provided with n wires, and what we'll do is we'll take the ith wire and we will attach it to the ith segment of the pipe which is above, and we will attach it to the aith segment of the pipe which is below, right? So basically we have two terminals, not pipes, and what we'll do is we'll attach the ith pipe to anywhere in the ith segment of the first terminal, and in the second terminal we'll attach it anywhere in the aith segment. Okay, and we have to maximize the total number of intersection. As you can see, there are 4 intersections in this figure, and there are 6 intersections in this figure. Okay, and the way we can do that is we have to make a very simple observation here, that the ith wire and the jth wire will meet if and only if the value of a of I is greater than or equal to the value of a of j. Okay, so if I is less than j and I want to check whether the ith wire and the jth wire will meet, the condition that they have to satisfy is that a of I is greater than or equals to a of j. So the proof is again pretty simple, so we can just trivially see here. Let's talk about these two wires, the first and the second wire here. So if a of I, a of 1 is greater than a of 2, then it is obviously possible to construct these wires in such a way that they meet, right? You can try out several cases and you will find out that it is always possible to do so. I won't provide a formal proof here. And another thing is that if a of j is greater than a of I, for example, let's say that here a of 2 would be greater than 4, in that case you can still see that there is no way that these two wires will ever meet, right? So you can try to imagine something, and you can try to make diagrams and convince yourself that this is the case. I don't think it deserves a formal proof, and kind of basic intuition works here. It worked here for me. So yeah, this is the solution. So to solve h1, you can just have an O of n square loop, and you will just find out these values. But to solve h2, what I did is I used an ordered set, but you can use various other methods. I mean, there are much simpler methods here. You can use a Fenwick tree, or you can use a lot of other data structures which are available, but what I did is used an ordered set. So I iterated on the values of I from n to 1, and then I just found out the number of elements in the suffix which are smaller than my current element. Okay, and that's it. I incremented my answer by the number of elements which are, so aj has to be smaller than or equal to ai, so I just found out the elements which are smaller than or equal to ai and incremented my answer. Okay, so this is it. This is pretty much it. I have discussed all the problems. I know like this solution video was not very detailed, but I think it works, and I think this will be it for this video. So thank you for watching till the end, and I will see you in the next one.